So working on simplifying radicals for today. And first thing we have to do is talk about the different parts of a radical that we actually have. So right down here we've got the actual radical sign, which kind of looks like a long division sign, but it's got that little extra piece to it. Within the radical sign we have two parts. We have the index, and then we have what's called the radicand. So the radicand is the number that you're trying to find the roots for. So if it's a perfect square, it works out really well, but sometimes it's not. Your index identifies what kind of root it is that you're looking for. So for example, let's say I had a little 2 out there. That means I have an index of 2. This means I'm trying to find my square root. Yes. Now, because the square root is so common and it's the one that we use the most, more times than not, you won't actually see the 2 there. It's just, if there's no 2, it's always a 2. Another one you might see a little bit this year is with a little 3 out there. So that means we're looking for the cube root. So what number times itself 3 times gives you the number underneath the radical sign. If it had a 6 out there, that means you're looking for the 6th root. What multiplied 6 times gives you that number underneath. But we're going to be pretty much dealing with square roots. Occasionally we'll have a cube root in there, but not very often. So our perfect squares, those ones are pretty easy to deal with. If a number is a perfect square, that means when you go to take the square root of it, you don't have a decimal answer to it. So for example, 100 is a perfect square. The square root of 100 is 10. The square root of 49 is 7. And the square root of 16 gives us a 4. So when they're perfect squares and you need to simplify, it's pretty easy. You just take the square root of the number and that's what you get. They're not always going to be perfect squares though. So in order to simplify radicals that are not perfect squares, you do need to keep in mind what your perfect squares are, and you kind of want to create yourself a little list of them. So if you're unsure of how to create the list, it's actually pretty easy. Start with the first number, so you start with number 1, and you square it. So what is 1 squared? So that's our first perfect square. Then we go to our next number 2. What is 2 squared? 4. And then our next number 3, what is 3 squared? 9. And then 4 squared? 5 squared? 6 squared? 7 squared? 8 squared? 9 squared? 10 squared? 11 squared? 12 squared? 13 squared? Yeah, that's where I always lose you. 169. 14 squared, 196. 15 squared, 225. And then I put my dots because it keeps going on forever. Your perfect squares is actually an infinite list. It means it keeps going on forever. There's an infinite amount of perfect squares. You should at least memorize those first 15. It's going to make our lives easier. So again, a lot more than 15, but those are going to be our most common ones that we're using, so you should get those ones memorized. It's going to make our lives easier. So if we take a look at examples on the bottom, the first one is going to be a little bit easier than the other ones because 36, is that a perfect square? Yes. What is the square root of 36? But what do you think happens with this out here? Makes it negative. So negative 6 is our answer there. So then looking at our next one, is 18 in our perfect squares list? No. So what we need to do is we need to find the largest number in our list of perfect squares that multiplies in or divides into 18. 18 divided by 4? 9. 9 times what? So my 9 goes first because that's the perfect square. 2 goes second because it's 9 times the 2 that gives you the 18. And again, 9 is your largest perfect square that goes into 18. So what is the square root of 9? 3. So that comes out as a 3. There's no more radical sign on the 3 because you used it to change it from the 9 into the 3. So we don't write that anymore. 2 stays underneath the radical sign. So we get 3 radical 2 is our simplified form because it's not a perfect square. So when it'll give you the phrase in simplest radical form. So that means you have to leave any non-perfect squares in a radical. If you couldn't find a perfect square, well, then you take care of it. Then you would take care of it. That if the 2 also was a perfect square, that means the original number was a perfect square and you didn't need to separate it at all. Because if the original is a perfect square, you take the square root of it and you're done. You do this if it's not. So like 125, not a perfect square. 25 is our largest perfect square that goes into it, but 25 times 5. So now the square root of 25. And then this 5 stays underneath the radical, so we get 5 radical 5. So my fourth example there, 16, is that a perfect square? Yep, so I just take the square root of it. What is the square root of 16? And then what do you think we do with that negative 3 out there? We multiply it, so it's negative 3 times the 4. So we get negative 12 as our final answer. Because it's negative 3 times the radical, so once I simplify the radical into a 4, it's still negative 3 times it. 2 things next to each other means multiplication. Fifth example, is 20 a perfect square? Nope. What is our largest perfect square that goes into 20? 4 times 5. So 4 goes first. Square root of 4 is a 2. 5 stays under the radical. What do I do with this other 2 that was already there? Multiply it by the 2 that we got from the 4. 4 radical 5. Then our last one, 63. Is that a perfect square? No, it's close though. 64 is a perfect square, but not 63. 9 times what? You're right the first time. 7. 9 times 7 gives me my 63. Square root of 9. 3. And again, I got to multiply that 3 times the 1/9. Anything that was out in front gets multiplied by anything that comes out of the radical sign. 1/3. Which is 1/3. There you go. Same process. You find your perfect square, divide it out, and take the square root of it.